We will cover how Jama's intelligent, guided, and measurable product development approach enables us to launch products to market faster, reduce product recalls and re-engineering, how we can leverage Jama's engineering AI to automate manual day-to-day engineering tasks, how we can natively co-develop with external subcontractors and contract manufacturers in Jama so that we achieve a central source of truth across our entire engineering data, as well as external traceability, and how we can better leverage product cybersecurity, safety, and risk management in the context of our integrated consumer electronics development. In Jama Connect, we use process models to define end-to-end product development processes, starting from the ideation, definition, and design of our products, all the way till the manufacturing, software development, and testing. Jama Connect will use these models to guide engineers through the end-to-end development, automatically measure system and process completion, and automatically detect gaps and risks so that organizations know where to take action. Our out-of-the-box consumer electronics solution contains process guidance for the development of integrated consumer electronics products like laptops, phones, computers, or tablets, as well as for the development of consumer electronic subsystems like battery systems, displays, or systems on chips, as well as for the development of standalone software consumer applications. Within Jama Connect, we can measure and manage the end-to-end traceability from the definition of the product from the highest level of the stakeholder need all the way down till the part and line of code. As part of the development of an end-to-end consumer electronics products, practitioners are integrating Jama with multiple other tools for task management, source code management, and product lifecycle management. Jama will exchange data bidirectionally and continuously with these tools so that in Jama we can manage the impact of changes across the end-to-end engineering data, and so that in Jama we can measure completion and detect gaps programmatically across the digital thread. For example, here on the left we can see a project tree. This project tree will enable findability across the entire engineering data and will enable us to display our product structure, including the components, subsystems, and disciplines that are part of those subsystems and components. The project tree is entirely customizable. For example, within my software component, I can find the software user story, which is linked in traceability with the software functional requirement. This software user story exists in Jama and is bidirectionally and continuously synchronized with tools like Jira, Azure DevOps, as well as with manufacturing tools for parts or design tools for models and architectures. The developers, the mechanical engineers, the designers, they will not make any change to their way of working, and Jama will manage the end-to-end traceability from the highest level of the requirement all the way down till the implementation. Jama will then measure product completion and detect gaps, as mentioned before, across the entire product data. Here, we can see to what extent the decomposition of our requirements, the testing against the requirements, or the allocations to architectures is complete. And due to the integrations with other software development, task management, or mechanical tools, we can also measure the completion of the implementation and development of our system. This capability enables organizations to know where they have their biggest gaps and product risks so that they know where to take action. And this type of intelligent product measurement hasn't been possible historically. For teams developing standalone consumer electronic software applications, Jama Connect can exchange data bidirectionally and continuously with source code management tools like GitHub and GitLab to enable end-to-end live traceability and the understanding of the impact of changes from the requirements all the way to the lines of code. Product line engineering is a very important part of our consumer electronics framework. In this project, for example, I'm working on the development of a laptop. This laptop has multiple other variants our engineering teams are working on in parallel. And with a couple of clicks, we can get an overview of all of our variants, as well as understand the delta between variants with respect to requirements or designs that are only part of one variant, or with regards to shared requirements which are part of both variants 1 and 2, but slightly different in each product to fulfill the needs of the variants. Once we've identified the differences, Jama will allow us to synchronize changes between variants or across our entire product library. These capabilities enable product modularization and help reduce the time needed to start the development of new generations. In Jama, we can also maintain libraries of subsystems, systems, or standard requirements. In this example, I'm maintaining multiple battery versions, multiple versions of a subsystem, and whenever appropriate, I can reuse the respective subsystem version in a new development project. Jama enables multiple product line engineering approaches which our customers find very useful. The first one is the approach of the library. From the libraries, we will be reusing content in different product projects. The second one is the approach of a technology platform, where we would be setting up a 150% product containing all the data that we could ever use in a variant. And then when a new release starts or when a new generation product starts, we can branch off the necessary content from the technology platform in the variant. Jama also enables us to work on multiple releases in parallel and bring over changes from one release to another. And the product line engineering approach in Jama is entirely customizable. Another very important component of our consumer electronics solution is native code development. Consumer electronics companies very often work with external subcontractors and contract manufacturers for the development of subsystem technologies. Contract manufacturers can create engineering contents natively in the same environment with the OEM, so that the OEM can manage end-to-end traceability and detect gaps externally towards the data provided by the subcontractor. Here as an example, we can use Jama Connect to measure the external traceability. We can see that only 20% of the specifications that we've defined internally have been implemented with designs or parts from our external subcontractors. Functional safety as well as cybersecurity starts being more and more important for consumer electronics companies. The consumer electronics framework contains out-of-the-box safety, cybersecurity, and failure modes and effects analysis data models, which will enable companies to manage risks and the mitigations of those risks as part of one integrated process with the other functional and non-functional elements of the consumer electronics products. The out-of-the-box data models will enable for the automatic calculation and classification of the cybersecurity threats, definition and analysis of the safety risks, as well as the failure modes. We believe that artificial intelligence is crucial to reductions of time to market. In Jama Connect, we are able to automate key day-to-day engineering tasks. For example, I will manually create a requirement. The laptop shall maintain Wi-Fi connectivity. And then, historically, to test against this requirement, engineers would have needed to define the test manually. They would have described the parameters and the objectives and then define the steps that the executor would need to go through. Jama's engineering AI will derive tests automatically and massively reduce the time needed for test generation and validation. The QA engineer can choose to take over one of multiple tests created by AI, and Jama's AI will link the tests in traceability with the requirements automatically. Jama's engineering AI can help automate multiple day-to-day engineering tasks, like the generation of requirements, the refinement of requirements, or the creation of traceability across the end-to-end process. Our AI relationship discovery will enable the user to define what relationship suggestions they'd like to receive. For example, I can choose to ask Jama to show me subsystem requirements and system architecture traceability suggestions for my system requirements. And then Jama will query our product library and display multiple objects which we can choose to relate in traceability with our source objects. The user will have the ability to visualize the content of the suggested relationship, and then will be able to intuitively create a traceability link between the source object and the suggested object. Thank you very much for your time. If you'd like to find out more about our consumer electronics solution, please visit our website. Thank you.